All right, I'm going to do some of these review problems with you guys. There's 48 problems in here. I don't know if I'm going to get through the whole thing, but I'll try to get through as much as I can. Let's start with the graphs. There's two ways I taught you guys how to do this. You could either make a table and pick some values, or you could pick the 2 points based on the parent function and then graph it from there, your transformations. All right, so if you do it the way that I showed you guys, the 2 to the x is going to have the parent function 0, 1, and 1, 2. So if you plot those points, it looks something like this. Right, so I know it's going to look something like that. And then that +1 is going to tell you to go up. So then those 2 points that you plotted, you can take those and go up 1 unit. So I'm going to take my entire graph with it and go up. All right, so it should look something like that in blue. And blue would be your answer. All right. If you wanted to make a table, right, that's the other way that I showed you guys to do it. If you didn't like picking the 2 points and then making a table, and transforming it, you could always make a table, and then you'll get more accurate points to plot. All right, but something like number 2, for example, a couple ways that you could go about doing this one, right? So you could either do the same thing, right? 0, 1, 1, b. So you get something like that. But then this negative inside of the exponent is going to flip it across the y-axis, right? So that's a y-axis reflection. I'm going to get something that looks like that now, right? So then we get points that connect and look something like this. So you could do that. You could also, if you don't like the negative exponent, turn it into a positive, right? This negative exponent, to turn it into a positive, is going to become 1/2 to the power of x. All right. And then 1/2 to the power of x, you can just use the same points, 0, 1, and 1, 1/2, and then just plot those as normal, right? You see that that's pretty much what we plotted already. Or make a table, right? If you make a table, pick a couple points, and then you'll get an accurate graph. All right. Something like this one, we can do the same thing, right? Our parent function here would be 2 to the x, so our points would be 0, 1, and 1, 2. So something like that. And then that -2 in the exponent, right? Remember, if it's in the exponent, it's a horizontal translation. So it's going to go over 2 units to the right. So this graph that we drew, or those points that we plotted in green, we're going to now transform them 2 units to the right, and it's going to look something like that. All right. We could do the same thing with number 4. Right? Number 4, your parent function here is going to be this 1/4 to the x. We get the points 0, 1, and 1, 1/4. If you wanted to pick another point, right, so maybe those points, if you were to plot them, right, I'll plot them right here, are a little too small for you guys. Maybe you want to pick another one. You can pick -1. If you plug in -1 here, then we get, with the original graph, right, 1/4 to the -1 is going to get us a +4. All right, if you didn't like that, just make a table with what you're given already and then transform it accordingly. So then we get some points like that. That's what the original looks like. And then we have a couple transformations. We have a -2 that's going to go to the right 2 units. So 1, 2, 1, 2, 1, 2. It's going to look something like that. And then we have a +1 that's going to go up 1 unit. So 1, 1, and 1. It's going to look something like this. All right, so in purple is what our graph is going to look like. If you don't like all those points, you can always make a table, all right? I always encourage it if you're ever unsure, all right? But it's always going to look like one of 2 shapes. It's either going to look something like that if it's a growth, or like that if it's a decay, right? And you could have some other transformations that, I don't know, flip it a certain way, but regardless, it's always going to look something like that. All right, so here, this page is just questions where I ask you guys to solve, right? A lot of you guys are pretty good at this, right? So, but I'll still go over it, right? So the goal here is to get the same base, right? In all of these problems, at least with what you guys have learned thus far, they're always going to have the same base one way or another, right? So That's your clue to always check, right? And make sure that they have the same base. So something like 3 to the x plus 1, right? We have a base of 3 here. 27 you can rewrite to have a base of 3. It becomes 3 to the power of 3. And then now that they have the same base, the 3 and the 3, you can cancel that out, and then you get x plus 1 equals 3. Right, subtract 1 on both sides, and then it just becomes a regular linear equation, and you get x equals 2. All right, pretty simple. All right, same thing with the next one. The next one's another pretty straightforward one, right? I see a 2 and a 64. 2 I'm going to keep. I'm going to change the bigger one to have a base of the smaller one, right? 64 you can rewrite as 2 to the power of 6. All right, and then this 2 and this 2 are going to cancel out, and then you get x minus 2 equals 6. You can add 2 on both sides, and then you get x equals 8. All right, next one. I know the fraction might throw a lot of you off, but you can easily make it not a fraction by using some properties of exponents. Now, if you make this x up top a negative x, that's going to bring this 2 up to the top, and it's going to become 2 to the negative x is going to equal 32. And then 32 you can rewrite as 2 to the 5th power. And then now that you have the same base, you can cancel them out, and then you get negative x equals 5. You can get rid of that negative in front of the x by multiplying or dividing by negative 1, and you get x is negative 5. All right. Something like this one is the same idea, right? So I have a 125 on the bottom. You can bring it to the top by changing it to the exponent to a negative. I would first change it to 1 over 5 to the 3rd power. And then 5 to the 3rd you can bring up top by making that exponent negative, and then you get 5 to the x minus 2 equals 5 to the negative 3. And then you can cancel out your bases because they match. And then you get x minus 2 equals negative 3. Or you can add 2 on both sides, and then you get x equals negative 1. All right. And then next one, right, with the e's, these already have the same base, right? So there's nothing new about it. You just have an e in place of, I don't know, just any number. You can still cancel them out, and then you get 3x plus 2 equals 3. And then you can just solve for x like normal. So we get 3x equals 1. Divide everything by 3. And you get x is 1/3. All right. Something like this one, e to the 2x, or e to the 2 to the x is the same as e to the 2x. All right, so that's the only thing that you had to do. A little bit redundant to write it again, but regardless, you can still cancel them out. And then you're left with x squared minus 3 equals 2x. And then you can subtract 2x on both sides. And then you get x squared minus 2x minus 3 equals 0. And then you can just factor this and solve. So you get x minus 3 times x plus 1 equals 0. And then you get two solutions here. You get x equals 3 and x equals negative 1. All right, let's keep going. Another one with e's. All right, so the e to the, or 1 over e to the 2nd power, you can change it to a negative and bring it to the top. And then e to the 4 to the x minus 1, you can distribute the 4. You get e to the negative 2 equals e to the 4x minus 4. Cancel out your e's, you get negative 2 is 4x minus 4. You can add 4 on both sides, and then we have 4x equals 2. Divide both sides by 4, and we get x equals 1/2. All right, and then 12. We see a square root. The square roots you always want to change into a fractional exponent, right? So we should know by now that 1/2 can be in place of a square root if it's in the exponent. And then 1/2 times 4x is going to get us 2x. And then 27 we can rewrite as 3 to the 3rd power. So 3 to the 3 to the 2x equals 3 to the 12x minus 18. And then 3 to the 2x, you can rewrite that as 6. So it's 3 to the 6x equals 3 to the 12x minus 18. Cancel out your 3's, and then you get 6x equals 12x minus 18. And then from here, just solve for x. You can subtract 12x on both sides, and you get negative 6x equals negative 18. And then you can divide both sides by negative 6, and then you get x equals positive 3. All right, so this page is just compound interest problems. You absolutely need to know the formulas. For regular compound interest, it's going to be A, your accumulated value is P times 1 plus R over N to the NT. For continuous interest, so anytime you see a problem that says it's compounded continuously, it's going to be PE to the RT. All right, and you should know how to label all of these already, right? So this was in a lesson in 5.1, right? So we should know how to pull this information from a word problem and then plug it into the formula, right? You will get a calculator for this portion, but you still need to know how to set up the equation, right? So if you look at number 13, right, this employee receives a 1.5% raise semi-annually. So I'm going to label what we have so far. I have a rate. As a decimal, it's going to be 0.015. Semi-annually is going to be a compound in a given year, right? So if it's semi-annually, that means he is getting a raise twice a year. All right. The initial salary is going to be this much, 62,800, and this is going to be our principal value. That's how much we start with. And you want to find the salary after 6 years. This is T, your time. Your time is always in years. All right, so I'm going to just plug this into our formula. A equals P, which is 62,800, times 1 plus R, which is 0.015, over N, which is 2 to the power of 2 times 6. All right, make sure you know how to use your calculator. All right, because this, I can't really help you if during the test you have calculator issues. All right, but really from here, what you would do is you would just plug it into your calculator. And if you do that, then you should get that this is, I'm going to round to the nearest cent. All right, this is going to be $68,691.07 is how much this employee is going to get after 6 years of raises. All right, now if you have a savings account and it's compounded monthly, right? So keep in mind, compounds is the amount of times in a year that you're collecting or building interest on top of itself. So N, in this case, is going to be 12, right? If it's compounded monthly, that's 12 months in a year. The interest rate is 4%. As a decimal, it's going to be 0.04. And you're currently investing that much in your savings account, 1,882, and you want to find the balance 9 years from now. That's your T, your time in years. So once again, your time is always going to be in years. So I'm going to plug this into my formula. All right, 1,882 times 1 plus 0.04 over 12 to the power of 12 times 9. All right, and then once again, from here, it's just plugging it into your calculator. All right, and then you should get approximately $2,695.91. All right, now the next one says compounded continuously. Continuously, this is your clue that you're going to use the other formula, the PERT, PE to the RT. That's one way to remember it. Continuously, you're going to use that E constant. Your rate is going to be 2%, so as a decimal, 0.02, and your current balance is this much, 1,576, and you want to find the balance 7 years from now. That's your time. So my accumulated value is going to be 1,576 times E to the 0.02 times 7, and plugging this into your calculator, right, you can put it in exactly as you see it. Should get you approximately $1,812.83. A lot of you were asking me, how do you get E on the calculator? If you have a scientific, or really I think most scientific or graphing calculators it's going to be second. And then after you click the second button, it's going to be ln, right? It might be capital, it might not be. In my calculator, it's capital, so it's ln. And then it should auto-generate an e with a caret and a parentheses. All right, so that's telling you e to the power of whatever you're going to put in parentheses. All right, and that's how you would get it on your calculator. The last one on this page is another compounded continuously. You're going to use this formula, PE to the RT. Your principal is 1,419, your rate is 3%, and you want to find the balance 8 years from now. So it's going to be 1,419 times e to the 0.03 times 8. All right, take a minute, plug this in your calculator. And you get approximately $1,803.90. All right, there's a lot of these problems where I ask you to convert from log to exponential or vice versa. It's going to be the same process every time. I like to circle the base and then draw the arrows. So if, for example, this one's 4 squared equals 16. A lot of people like to label it BAE or BAE, base answer exponent. You get a base of 9. This is a typo. This should have been positive 2. So you get 9 to the second power equals 81. Or, I don't know, I think those are the only ways that I've seen it, right? So this one, for example, I like to draw the arrows. You get 32 to the 2/5 equals 4. Or for this one, if you like BAE, this is your base, this is your answer, this is your exponent. It's going to be 12 to the first power equals 12. All right. Same exact thing if you were going from exponential to logarithmic. Your base is going to be 24, so I'm going to circle it and then I'm going to loop around. I have a log base 24 of 1 is going to equal 0. Or you can label it, this is your base, this is right here is your exponent, and then this right here is your answer, right? And if you rearrange it so that it's in the order of BAE, then you get a log of 4 of 1 over 64 equals your exponent, -3, right? It doesn't really matter how you do it, just as long as you know how to go from one to the other. All right, so this one, I use the arrows. We get log base 5 of 125 is 3. This one, I'm going to use BAE. Base, this is your exponent, and then this is your answer. All right, so rearrange it so that it's in the order of BAE. We get log base 9 of 27 is going to equal 3 over 2. All right, and that's all you have to do for these. These evaluate problems, there's a couple ways that you could tackle them. A lot of you like to set it equal to something, like a variable, and then solve it that way, convert it to exponential. So if I set it equal to x, I get 2 to the power of x equals 64. 64 I can rewrite as 2 to the 6th power, and then my 2's cancel, and so I get my answer for this one is 6. All right. If you didn't do it like that, you would have converted the 64 to 2 to the 6th from the beginning, right? So I'll show you that right here. You could have converted it to 2 to the 6th power, and then a property of logs is that these are going to cancel out, and you're just left with whatever's in the exponent. Right, so that's something that I would do for 26, for example, because I don't like having too many variables in one problem. Right, so if you wanted to convert it to exponential, there's already an x here. So I would set it equal to y or something like that. And I would convert it to exponential. So we get 7 to the y equals 49 to the x. And then I want to see what can I get 49, or what can I change 49 to get it so that it has a base of 7. And it's 7 to the y equals 7 to the 2x. And then you can cancel out, and then you get y equals 2x. That means this logarithm is going to become 2x. All right. If you didn't do that, right, you would have changed 49 to the x to be 7 to the 2x right away, and then you can just cancel out your bases, and you're just left with 2 to the x. All right. I'll show you with 27, right? This is something that I wouldn't actually convert to exponential because this is a property, a super easy one at that. Anytime you see 1 on the inside of your logarithm, this is always going to get you 0. And you can always confirm, if you raise 8 to the power of 0, you do get 1. All right? And then something like 28, this is another property, right? So log base a and a are going to cancel out, and you're just left with -2. If you didn't like that, you would have set it equal to something. So like log base a of a to the -2 equals x. Convert it, we get a to the x equals a to the -2. And then your bases cancel, and then you still get an answer of -2. But knowing the property made it a lot simpler. All right, so more evaluations. This one is another one that you can use a property. If you have a base a raised to a logarithm of the same base, then you're just left with whatever's on the inside. All right, not much work to do there. This 8 and this log base 8 can't match up, so we can cancel them out. ln and e are another pair that cancel out, right? ln, remember, is log base e. So if we have log base e of e to the 1/2, they're going to cancel out, and so we get 1/2 as our answer. All right. So the properties, I told you guys, if you don't memorize them, be sure you know how to convert from one form to another really effectively, because that's going to save you on these kinds of problems. But I wouldn't recommend that. I would recommend just knowing some of the properties. The more you do them, the easier it gets. All right, so something like this is another one where we can use some properties, right? Number 31, we can use the one-to-one property of logs, and then you can cancel out your ln's, and then you just get 2x plus 9 equals 3x plus 1, and then you can just get your x by itself. All right, so we get here x equals 8. All right, 32 we can convert to an exponential equation. 3 to the power of 3 equals whatever's on the inside. So I get 3 to the third equals 3x plus 2, and then you get 27 equals 3x plus 2. Right, you can subtract 2 on both sides. And then you get 3x is 25, so you can divide both sides by 3, and you get x equals 25 over 3. All right. This is the new section. So from here onwards in this review, this is all 5.3 forward, right? So 5.3 was where we had more properties of logarithms, and these you absolutely need to know for your test, right? So in 33 through 36, I'm asking you to rewrite as common and natural logs and then evaluate. So common, hopefully we remember common log is, right, so this was log with no base. Natural log was ln, right? So if you don't see a base, you always assume it's 10, right? So that's something that you guys cannot forget as well. The log button that you see in your calculator, it doesn't give you the option for a base because it's a log base 10. All right, so if I wanted to rewrite log base 5 of 16 in terms of common logs, it would be log of 16 over log of 5. All right, and this was our change of base formula. And if I wanted to write it as natural logs, it would be ln of 16 over ln of 5. And then if you put this in your calculator, I didn't give you guys any specifics of like how many decimal places to round this one. You'll know when it comes time for your test. But if you plug this into your calculator, then you get about 1.723. All right, I'm just going to say 3 decimal places is fine. All right, the next one is another one, right? So your calculator can't do this, but you can convert it into common logs, log base or log of 4 over log of 1/5. And then this is the same as if I had ln of 4 over ln of 1/5. And then I can just put this in my calculator. And this is going to get us approximately negative 0.861. Right, you're allowed to have negatives. Right, you're always allowed to have negatives as your answer for a log expression. All right, same thing with the next one. It would be log of your big number over log of your little number. And then this is the same as ln of your big number over ln of your little number. All right, putting this in your calculator is going to get you about 2.579. All right, and then the same thing with the last one. I know the pi is a little strange, but still, same exact thing. We have log of 0.5 over log of pi. And this is the same if I had ln of 0.5 over ln of pi. All right, so I just want to put this in the calculator, and then we get that this is about negative 0.606. All right, so that's all the new stuff. There's going to be more of the new stuff in the next page, right? But that's all a change of base. All right, so this is also new stuff, but this is stuff where we would use our power product and quotient properties. You'll see questions like these on your test where we're going to give you some values, and you're going to have to figure out what to do or how to solve problems like log base b of some number, right? So in number 37, log base b of 10, I have no idea what b is, but you don't need to know what b is because we're going to give you a couple useful values that are going to help. Now 10, we can see that you can rewrite 10 as 2 times 5, right? Now this is an example of where you can use your product property and you can change this into log base b of 2 plus log base b of 5. All right. Now what I would do from here is I would just plug in the values that were given. All right, and then compute it. Right, these are values that we are given already, so we know that we're going to have to use them at some point. And then if you put this in your calculator, all right, this is going to get you 1.1833. All right, now the next one, log base b of 45. 45 is another thing that we can rewrite in terms of information that we're given. So we have a 2, 3, and a 5. Can we rewrite 45 in terms of any of those numbers? We can. Right, so 45 can be rewritten as 5 times 9. We don't have a 9, but we have a 3, and I know that 3 can be, I know that 9 can be rewritten as 3 squared. So I can use my properties of logarithms to expand this expression. So I get log base b of 5 plus log base b of 3 squared. But remember that exponent can go out front as your coefficient. So this is going to be log base b of 5 plus 2 log base b of 3. All right, and then I have approximate values given, so it's going to be 0.8271 plus 2 times 0.5646. All right, and then if you put this in your calculator, this is going to get us 1.9563. All right, something like 2 divided by 3. I don't know what log base b of 2 divided by 3 is, but I know that with that division, we can turn it into a subtraction. All right, so this is going to become log base b of 2 minus log base b of 3. And I have those values, right? So I'm going to use my approximate values of 0.3562 minus 0.5646. And then this is going to get us negative 0.2084. All right, and then one more like that is going to be 16. I don't know what log base b of 16 is, but we have a 2. We can rewrite 16 in terms of 2, right? It's going to be log base b of 2 to the 4th power. And then a 4th power you can rewrite in the front of your log. So it's going to be 4 times log base b of 2, and that's 4 times 0.3562. And that's going to get us 1.4248. All right, so you'll definitely get some problems like that on your test. You'll also have some problems where we're just going to ask you to expand or condense, and that's just the remainder of this review. So if I want to expand, look at what operations we have on the inside of our log. All right, so here, notice that we have a 7 times x. If I have a times, that's going to become a plus between logs. So it's going to be ln of 7 plus ln of x. And then if you look in each of our ln's now, we don't have any more multiplication, division, or exponents. So this is our answer, fully expanded. All right, the next one, 42, I'm going to look at what we have on the inside of our log base 8, and it's an exponent of 4. I know that an exponent can go out front of my logarithm, so it's going to be 4 log base 8 of x. And there's nothing more we can do to that. There's nothing more inside of our log base 8 that we can take out or separate, so we just leave it as is. Something like this one, notice that I have a ln of xy to the third power. This whole thing is being raised to the third power. We see parentheses. So I'm first going to take out that 3 ln of xy, and then notice that I have an x times y. All right, times, I know that that's going to be an addition between logarithms. So it's going to be ln of x plus ln of y. And then this 3 is being multiplied to this entire thing. So I'm just going to write it out front with parentheses. And then it's going to look something like that. All right. The next one, right? Notice what operations we have on the inside of this. I see a division, which is going to give us a subtraction between logs. And then I see an exponent, and I know that that's going to go out front. Right? So I would first do the division because that's what's happening to the entire thing on the inside. So it's going to become a log of w squared minus log of x. And then this exponent right here is going to go out front. So it's going to become 2 log of w minus log of x. All right. And then lastly for this review, condense. Condense means to make it into one single expression, right? So it's now you're looking at what's happening on the outside of your logarithms and you're trying to make it into something that can be pulled into one single log. So I see a plus on the outside between our logs. I know that's going to be multiplication on the inside. So I'm going to have an ln of 3x. And there's nothing more you can do to that. We already have our single log, so we just leave it as is. 46, I see a minus between my logs. I know that's going to be a division. And then I see a 3 out front. I know that's going to become an exponent. So right now I have a log of 8 minus log of t cubed. And then now I can take care of that minus, and it's going to become log of 8 divided by t cubed. And now we have one single log. All right. Now the next one, another one, I have a 1/2. I can put that on top of my x minus 4. So this is going to be ln of x minus 4 to the 1/2. Keep in mind, to the 1/2, that's the same as taking the square root. So this is going to be ln square root of x minus 4. All right. And then this last one, I see a 2 and a 4 that can be brought up to the exponent. And then I also see a plus in between, and I know that that's going to be a multiplication. So I know I'm going to have a log x to the power of 2 plus log y to the power of 4. And then take care of your multiplication, right? Then I'm going to multiply whatever is on the inside. So I have a log x squared, y to the 4th, right? Multiply them, and then you get something like that. All right, and then that covers everything that you're going to see on your test, all of the major skills and topics that you're going to need. Make sure you're comfortable with everything on here, all right, because it will show up on your test.